Okay, so I've drawn the angle bisector. Now, check out the top triangle, right? And the bottom triangle here. We constructed these two segments, we'll call them AB and AC. We constructed them so they were the same length, right? Then we went from B, we made an arc here. We went from C, we made the same arc here. So BD and CD are also the same length. And what about AD? Is it congruent to itself? So our two triangles are congruent by side, side, side. And that means that these two angles are corresponding parts of congruent triangles. I know they're congruent, so I know that this line is an angle bisector. So that's how the construction works. That's how we prove the construction. So now, we know what happens when we draw the perpendicular bisectors of a triangle. They're concurrent, correct? They're concurrent. And the point of concurrency, what's it called? Circumcenter. And we know where it is, right? It's different triangles. And it's equidistant from the vertices, right? Let's see, what was this one? Remember the angle bisector? Remember how if we start anywhere on the angle bisector and we go to the sides of the angle, that those two segments are congruent. So the angle, any point along the angle bisector is equidistant from the sides of the angle. So now, let's look at how that happens in a triangle. So I'm just going to draw a triangle. I don't want to make it too regular, but okay. Now I need to construct the angle bisector for each angle, and you're going to have to be able to do this. Okay, so remember what we did. We're going to do the exact same thing. I'm going to come here, I'm going to make an arc somewhere, doesn't matter where, and then I'm going to go from that point, I'm going to make an arc out here, and then I'm going to come from this point and I'm going to do the same arc, and very carefully I'm going to find right where they intersect and be very careful to go right from the vertex here. Okay, so that's one angle bisector. These two angles are congruent. Now can we repeat that? Can we do it again? Okay, you don't have to do anything new, we just have to do that again. So I'm going to come up here at this point and I'm going to make an arc, and then I'm going to come down from that. Now I'm really careful to make sure that's right on the money there. I'm going to make my arc, and then I'm going to come over here, do the arc again. Now if you get these too close, these things, they almost get looking like the same arc, and it's really hard to tell where the intersection is. So make sure they're out there a ways, and then you find right where they intersect. We draw that angle bisector in. So these two angles are congruent. Now notice they intersect, right? So is that a point of concurrency? Good. How many lines or rays or segments do we have to have that intersect? Got to have 3. So wouldn't it be cool if we drew this one and it hit the same point? I wonder if that might happen. What do you guys think? Yeah? That would be cool if it did, huh? So when we come over here, and we're just gonna, and I'm trying to do these in 3 different colors so you can see what's going on. Now for you have your pencils, you can erase. Ooh, I'm not quite, I don't know if this is moving around or if my pen is so fine that it's moving around in that hole. What in the heck? I'm getting it. I can't even do it. Wade, does that look like yours yesterday? Mm-hmm. Yeah. Okay, I got it. So I've got my point of concurrency. So this point is called the incenter. So the circumcenter, is it always inside the triangle? No, sometimes it's on the hypotenuse, sometimes it's outside. The incenter, guess where it always is? On the inside of the triangle, okay? It's always inside the triangle. Now remember, any point on the angle bisector is equidistant from the sides of the angle, isn't it? So this point, if we're talking about the blue line, switch to green here. If I were to measure straight over here at a right angle and straight over here at a right angle and straight over here at a right angle, that point is equidistant from all three sides of the triangle. Okay? I can't circumscribe this triangle from that point, but I can that's a bit of a miss, but for me, I'm way off, but it's close. I can inscribe a triangle or a circle. So if we want to inscribe a circle on a triangle, then we find the incenter. You guys are just dying to do this one, aren't you? So I drew an acute triangle. Why don't you draw one that's definitely a right triangle or an obtuse triangle? Okay? And let's see if you guys can construct the incenter.